Okay, so this is section 3.4, and we're going to talk about two things. We're going to talk about library of functions. So we're pretty much just going to go over the graphs and the domain and range of some basic functions, and pretty much the ones that you looked at this week in lab. And then the second piece of 3.4, we will talk about piecewise functions. And so note that on the MyLabs Plus, there's actually two assignments for section 3.4. There's a part 1, and I think there's only maybe 4 questions, and it's just kind of identifying some of these basic graphs. And then part 2 is devoted to piecewise functions. So we will we'll do the same thing here. Excuse me. Okay. So first, let's just talk about those basic functions. Alright, we're going to start with f of x equals b. So this is just your basic constant function. So this is the same as y equals b. This is just a horizontal line that would go through b on the y-axis. So the domain, again, this will go to the left forever and to the right forever. So the domain is all real numbers. And the range is kind of tricky. What would the range be for this function? Well, let's see, there's nothing down here. It's right there. And then there's nothing above it. So the range is actually just a single value. And it would be b. All right. Now let's consider f of x equals x. Okay, again, degree 1. So this is a line, and it's a line that goes through the origin. So this is f of x equals x. So what was the domain? The domain, it goes to the left forever, it goes to the right forever. So the domain is all real numbers. It too will go up forever and down forever. So the range is also all real numbers. Okay. F of x equals x squared. Again, we've gotten pretty familiar with this one. We know f of x equals x squared is a parabola. So it looks something like this. If we're considering domain, it goes right forever and left forever, so we're at all reals. And range, remember, it does not go down forever. It starts at 0, including 0, and then goes up towards positive infinity. Alright, let's consider f of x equals x cubed. Alrighty. So if you remember from lab, f of x equals x cubed looks like this. And again, this will go to the right and left forever, and it will go up and down forever. Alright, next let's consider f of x equals the square root of x. Okay, so this graph, let me change color. This graph starts at the origin, and then we'll go like this. Okay, so in terms of domain, where does it start? It doesn't go to the left forever. It actually starts at 0, and then we'll go on to the right forever. And now what about the range? So now I'm thinking y values. It starts at 0, and it will go up forever. Okay, how about f of x equals the cube root of x? Alright, so this one looks something like this. Alright, so domain. Yep, it goes right and left forever, and actually it will go up and down forever also. Slowly, but it will. Okay, two more that we need to take a look at. Next, let's look at the reciprocal function. So f of x is equal to 1 over x. And if you remember, this one looks like this. And the domain, remember we want everything except for 0. So this is from negative infinity to 0, and then 0 to infinity, and the range is the same. And then last, let's consider f of x is equal to the absolute value of x. Alright, so this one looks like this. Okay, so domain, all real numbers, and range, 0 to infinity, just like the parabola. Okay, so you need to know these like the back of your hand. So you need to know what these graphs look like, and you need to be comfortable identifying their domains and ranges. Okay, so next thing we're going to talk about is we're going to use these as we talk about piecewise functions. So piecewise functions are really exactly what they sound like. We're going to look at pieces of different functions and put them together to make one function. Okay, so if you flip the page, it says we need to remember the graphs of the functions with their domains and ranges to graph piecewise defined functions. So, for example, if we look at that first one, we're given f of x is equal to, and then we're given two functions, x cubed and the absolute value of x. So this function is going to look like x cubed when x is greater than or equal to 0, and absolute value of x if x is less than 0. So you need to know how to graph this, be able to identify the domain and range of this function, and then be able to find specific values of this function. So let's go ahead and practice. Alright, so let's draw our xy plane. And we'll start with x cubed. Alright, so what does x cubed look like? Well, we know that x cubed, right, it looks like this. I'm just going to kind of draw it as a dotted line. Okay, so this graph is only going to look like x cubed when x is greater than or equal to 0. So that means I want this piece of the x-axis. Right, I'm concerned with x values starting at 0 and going to the right. So when x is any one of these, it's going to look like x cubed. So I'm going to go ahead and darken in x cubed for all x values greater than or equal to 0. So we actually won't need this piece of the graph. We can erase that. Okay, so now it's going to look like the absolute value of x when x is less than 0. So what does the absolute value of x look like? That's the pointy one when it comes down like this. So now it's going to look like that, excuse me, for values smaller than 0. So that would be on this side of the graph. So I'm going to darken in just this side. Alright, so let me make sure I still have my green. I can't draw a straight line. Okay, and then we can get rid of the dotted on this side. So you can see on the left it looks like absolute value, and on the right it looks like x cubed. Alright, so what is the domain of this function? The domain is from negative infinity to positive infinity because it will go to the right forever and to the left forever. And now what about the range? So it starts at 0, because 0 is in the domain, and then it will go up forever. Okay, and then also let's look at how we can define specific values. So f of negative 3. So what does that mean? That means when x is 3, what is f of x? So I need to consider this piece of the function. This indicates what the function is for numbers x values greater than or equal to 0. This indicates the function for x values smaller than 0. Since 3 is larger than or equal to 0, then when I go to plug in to find my value, I have to use x cubed. So f of 3 will be 3 cubed, or 27, which tells me that the point 3, 27 would be on the graph of this piecewise function, which makes sense, because if I go to 3, and then 27 would be somewhere up here. Alright, what about, let's see, we're also asked to find f of negative 5. So f of negative 5, since I'm plugging in a negative x value, I want to consider this piece of the graph. So f of negative 5 I plug into the absolute value function, and this will give me positive 5, which gives me this point. Okay, so the next example on your study guide is f of x is equal to x squared, negative 3, and 2x plus 1 given these domains. So what I'd like you to do is I am going to treat this one as a u-try. I'd like you to take a look at this and see if you can't make sense of the process and what's going on here. So you're going to take a look at x squared for values smaller than 0, negative 3 when x is 0, and 2x plus 1, remember this is a line with slope 2 and y-intercept 1 for values of x greater than 0. So see what you can come up with, try to think through it, and then also think domain and range and try to identify those specific f of x values that are on your study guide. But anyway, give this a shot and we will look at it in class.